This video will show how to analyze in Strand7 finite element program a cantilever beam 1.2 meter long and with a 4 kilonewton load. The cross section of the beam is a T-section, 100 millimeter wide and 100 millimeter high, and with a thickness of 5 millimeters. First, I'm going to set the units for this analysis as millimeters, megapascals, and kilonewtons. And I'm going to set the material for the plate. We are going to model the beam using plate elements with material steel, and in geometry the thickness of the plate is 5 millimeters. I will create 4 nodes. The bottom node I will say 0, 0. The next is at the top of the web. Then the left node is minus 50, 100, and the right node is 50 and 100. Redraw. So these are the 4 nodes. In order to create the plate elements, I will first create some beams and then extrude them. So I'll create these 3 beams, and because the whole beam will be meshed in by dividing it into 4 in each direction, I will now subdivide the beams into 2 on the top, so that the flange is subdivided into 4, and then I'll divide the web into 4 as well. After this, we can extrude the beam by increment, and there will be 4 increments, 4 plates along the length, which is 1.2 meters, so each will be 300 millimeters in the Z direction. I will raise the beam, and for the targets I will choose quad 8. Select all the beams and apply. Sorry, my mistake. I haven't set in the parameters to repeat 4 times. So by 300 4 times. This doesn't look right, but if you choose the view, which is maybe this one, it looks better now. So this it was the meshing. Now we need to fix all the nodes on this end and apply the load to the plates on this to the edge. The load is 4 kilonewtons, and the whole area of this cross section is 1000. So we can apply the load as the edge load. Now on the flange, the load is a normal shear stress, and its value is 4 kilonewtons divided by 1000 millimeters squared. It's 4 megapascals. And this will be applied on the edges. On the web, the load is in line of the web, so we need to apply it as the shear stress of the same value of 4. I will now change the angle of view to the ZX plane. This shows the load, so these are the nodes at the start, and I can select all these nodes and fix them. So attribute node restraint, fix, and select and apply. Now to see it better, I'll change back to the trimetric. Right, so all the nodes here are fixed. And now I can save the file. Case study 15. And I can run the solver, linear static solve. There are no warnings or errors, and checking the applied load, it's 4 kilonewtons, so that is correct. In the next file, I'm going to review the results in the next video.